Okay, let's do an optimization problem. We are trying to find a point or points on the graph of f of x equal to root x, which are closest to the point 4 and 0. Well, if you just sketch the graph of root x, this is something like this. And then the point 40, let's say somewhere here, 40. And what the question asks is that find the distance of these guys, which gives you the smallest. So if you go to different values, you see that it will have different distance, but this looks, the problem looks for the smallest. What point has the is the closest to the 4 and 0. Okay, let's start the steps. So first we have to do the modeling. So step 1 of the modeling is identify the variables. In the variables here, what it means, well, okay, so we have one thing is a point we denoted by x and y, a point on the graph. And well, we are trying to find the distance of 40 and points on the graph. Okay, so then step two is find the relations. Yes, find the relations or the equation, the relations. Here, what we know that since xy is on the graph um, of f of x equal to root x, that means that y is going to be equal to root x. In other words, we are going to deal with points of this form. That's the first thing to know. That's the first relation we know. The second one is that the distance is going to be, well, square root of, see here, we have a point here and we have a point there. So a distance of 40 from x and root x. So it means that you have to subtract the x component and square them. So x minus 4 squared. And then you do y, in this case root x minus 0 square, and then add them and put square root there. Well, this gives me root of x minus 4 squared plus root x squared is just x. We can do a little bit more simplification here. I can do right, well, it's already came out as a function of x. That's a good point here. And this is x squared minus 8x plus 16 plus x. And that gives us x squared minus 7x plus 16. Well, this step basically we did step 2 and 3, both of them here. And then the step 4 would be find the domain. Find the domain or possible values for x. Well, look at the graph. The graph exists almost for all x's which are positive. So this can be for any point which is positive up to infinity. So this means that x is coming from the interval 0 to plus infinity. That finishes the modeling, and now we have to do the second step. Find the absolute mean of the function. Here is dx is equal to x squared minus 7x plus 16 on the interval 0 plus infinity. Something that right here you have to notice is that the interval is not closed. So maybe we won't be able to use the tricks that we have learned, but here what we will do, let's try identifying the nature of local maximi. So using first derivative test, find relative max min of the function. Yes. Okay, so that means that we have to start with critical points. Critical points means that we have to find the derivative of b. Something here might be useful is that if you have square root of something, you want to find its derivative with respect to x, it will be u prime over 2 root u. So in this case, that will give me the derivative of x squared minus 7x plus 16 over 2 root x squared minus 7x plus 16. So this is derivative. Sorry, the derivative should be up there. And that gives me 2x minus 7 over 2 over x squared minus 7x plus 16. We set it equal to 0. There is a fraction equal to 0. Right away, that means that the numerator needs to be equal to 0, and that means that x is equal to 7 over 2. Well, this is the only critical point. Well, let's go and draw the table of sign for d prime. So in this case, it means that, okay, we have everything starting from 0 up to 7 over 2, then plus infinity. F prime is here, and then we will do the first derivative test. Okay, so here we know that f prime is 0. Let's plug in some value here. For example, the sample points here, we can put say what, 1. Yeah, 1 is something good. And here we will put something which is bigger than 7 over 4. Let's 7 over 2. 7 over 2 is 3.5, so let's just pick 4. So d prime at 1, this is d prime at 1, is 2 times 1 minus 7 over 2 root 1 minus 7 plus 16. See, the denominator is a positive number, but if you look at the numerator, you get minus 5 over 2 root some number. Yes, here is 10. This is positive, this is negative, so the whole thing is going to be negative. So that means that this part is a negative. And the d prime at 4 is 2 times 4 minus 7 over 2 root, well, something, yes, 16 minus, oh, it's bigger than 16. What is it? Okay, it's squared, yes. That is 16 minus 28 plus 16. The denominator is again going to be positive, but numerator, you look, this is 8 minus 7, which is 1. The whole thing is going to be positive, so then that means that this is positive. Okay, and when you have that, so the first derivative test test says that if f prime is -1 and interval f is going to be decreasing and then increasing. Yeah. Well, what does that mean? That means that f at 7/2 is a relative mean. But if you look a little bit carefully, you see that the function will decrease first to this value and then increase. So it's not only relative mean, but also an absolute mean. On the interval 0 to infinity, it first decreases to f of 7/2 and then increases to some other numbers, to infinity actually. Okay, what is this? What does this mean? It means that um, instead of D, I used F. So let me just turn these ones to D. So it means that the closest distance is D 7/2, which occurs at point, well, x is 7/2 and y is √x. So this is the point which is closest to the point 4 and 0. So 7/2 and √7/2 is the closest point on the graph of f of x equal to √x to point 4 and 0. So as all optimization problems go, we first need to do the modeling, then find the maximum or minimum, absolute max or mean of the function. That's how we do this exam.